Okay, let's have a look at this, see if these equations are compatible and see if there's any solutions. So CAST, sine is negative, sine is positive here and here, so it's negative there and there, and cos is negative, so cos is positive here and here, so it's negative there and there, so this must be the quadrant where the angle is, if it has such a solution. Mark off alpha and simply write sine alpha is equal to minus 0.342. We drop the negative if there is one to drop. And also from this equation we also have cosine alpha is equal to, and drop the negative if there is one to drop. Now if these equations are compatible, the alpha will come out as the same value on both equations. So let's have a look at that and see if it does. If it doesn't, there's no solutions. So shift sine 0.342, shift sine 0.342, 19.998, which means 20 degrees really. Basically, there might be slight error terms from the inaccuracy of the decimal. And shift cos is 0.94, 0.94, and again we've got 19.94. So I think that's trying to be 20 degrees again, isn't it really, for the purposes of the problem. So I'm going to assume that they are compatible, and within a margin of error these decimals are approximated, and we've got alpha is 20 degrees. Okay, good. Right, so alpha is 20 degrees, so the solution, come round to here. So come around 90, 180 and 20 more is 200. So that tells us that theta is equal to 200 degrees. And we could double check that on the calculator, couldn't we? We could do sine of 200, and we should come out with 0.342 with a minus, and cos 200. Let's see what we get here. Slightly more problematic. 0.939, which is not 0.940, which is within a margin of error. So then the intention of the question was to show that this was compatible, and that theta then comes out at 200 degrees.